Good morning, everyone. Thank you all so much for joining us today for our kickoff event for 2020's Earth Science Week. My name is JD Stucker. I am a geologist here with the Ohio Department of Natural Resources, Division of Geological Survey. And I am joined this morning by our Education Outreach Coordinator, Chuck Sammons, and our Coal and Industrial Minerals Geologist, Chris Wright. And we are going to be talking about a variety of topics here over Earth Science Week. The first which is going to be called Ohio Rocks and Minerals in Our Lives. And so before we jump into that, what I would like to do is I would like to take a second to kind of go through all the exciting Earth Science Week activities that we have planned for the coming week. Coming up here to kick off the official Earth Science Week, we're getting a little bit of an early start this Friday, is on Sunday is International Earth Cache Day, followed by Minerals Day on Monday. And you could follow along on our website, geology.ohiodnr.gov, and search Earth Science Week, or you can follow us on our Facebook page at Ohio Geological Survey to see some of the great content we have coming for those days and all next week. And our second webinar is next Tuesday on Earth Observation Day. Earth Observation Day, we're going to have presentations from geologists Daniel Blake and Krista Harden on sound waves in water and kind of an overview of our Ohio Seismic Network, which monitors earthquakes, and our groundwater monitoring network, which looks at different levels of groundwater all throughout Ohio. And next Wednesday is National Fossil Day. On National Fossils Day, paleontologist Mark Peter is going to be talking about fossils of the Columbus limestone, and geologist Brittany Perrick later that day will be talking about how to find Ohio fossils, where to find them, what kinds you can find, and some of the best practices for discovering them. Next Thursday is Geoscience for Everyone Day, and we're very excited to have a couple guest speakers that will be joining us to talk about reimagining the geoscience workforce for the future. And next Friday is Geologic Map Day, a presentation that we're very excited about. Several of our geologists are going to be coming in and giving a webinar on everyday uses for geologic maps. And they'll be talking about some of the different maps that they work on every day and how you can find ways to use them in your everyday life. And then to cap things off for Earth Science Week, next Saturday is International Archaeology Day. Once again, you can follow along on our website and on our Facebook page. You can also check out the Ohio History Connection next week as well to kind of find out some more information about International Archaeology Day. So that's a lot of talk about Earth Science Week and geology. And if you all have any questions during this presentation, feel free to submit them over in the Q&A over in the right of the webinar window. But when I talk about earth science and I talk about geology, what do I mean by that, right? Well, as many of you probably know, geology is the study of Earth's structure, all the substances and materials that make it up, and all the processes that act on those materials, and the history of all of it. And there's lots of different kind of areas of geology, subdisciplines. Many of you have probably heard of paleontology, right? Maybe you're familiarized with it from something like, Jurassic Park, the study of fossils and fossil organisms. You've probably heard of volcanology, right? The study of volcanoes. Seismology is the study of earthquakes. Hydrogeology, as you could guess, it's the relationship between geology and water. And then stratigraphy, you may have heard of. It's looking at all the different layers that are in the earth, how they formed, and the structures that are within them. But two areas that maybe aren't as familiar with are petrology, which is the study of the rocks themselves and the properties of the rocks themselves, and mineralogy, which is the study of minerals and the properties of those minerals themselves. And so as I start talking about like rocks and minerals in our life, what do I mean by rock versus mineral? Like what do those terms mean, and what are the differences between them? So what I thought would be helpful is if we kind of broke down some of the differences and similarities between rocks and minerals. So as you see here on the left in the red, you have rocks. We talked about that's the study of petrology. And on the right, we have minerals in the blue. That's the study of mineralogy. And so there's an analogy that I like to use to help explain the difference between rocks and minerals, and that is the cookie analogy. And we'll go with an oatmeal raisin cookie because I really like those. So in an oatmeal raisin cookie, you can think of the individual ingredients in that cookie as the minerals, and the entire cookie itself as the rock. So for example, some of the different ingredients might be, well, oatmeal, of course. You will have raisins, right? You have things like flour and sugar, and those are all, in this analogy, the different minerals, right? The ingredients that make up the entire cookie or the rock. And so the thing about those ingredients is minerals, they have a defined crystalline structure, right? The atoms are arranged in a particular way for every different mineral. And they also have a distinct chemical formula. So in this example, you can see on the screen, I have SiO2, silicon dioxide. That's the formula for quartz. So those are the distinct characteristics about a mineral. But if you look at a rock, just like an oatmeal raisin cookie, it's made up of many different minerals, right? And those different rocks can have different variable chemical formulas. They might not have a defined chemical formula like a mineral does. So for example, my oatmeal raisin cookie might have twice as many raisins as your oatmeal raisin cookie. And they're still both oatmeal raisin cookies, right? They still might both have the same name as a rock, but they have slightly different variable chemical formulas. Another interesting thing about rocks is that rocks can be organic, right? They can have organic matter worked into them. The best example of that is coal. Minerals, by definition, have to be inorganic. But there's also a lot of similarities between rocks and minerals. Rocks and minerals both have to be solid. They are both naturally occurring, and they're both mined and or used by humans in our everyday life. So before Chris talks a little bit later about all the different rocks and minerals that we use in our lives, I want to kind of put in perspective, how much do we use, right? So how many pounds of rocks and minerals do I use? And so the way I wanted to think about this is, if you were, the average American over the course of their entire lifetime is going to use this amount of rocks and minerals. So for example, the average American in their whole life is going to use over 30,000 pounds of salt, 1.4 million pounds of stone, sand, and gravel, 1,000 pounds of copper, 12,000 pounds of clay, right? These are some big numbers that they're going to be using. But you might say to yourself, well, I don't think I use 12,000 pounds of clay. But the way to think of this is, if we take how much is used in the United States and we kind of divide it up evenly among people, right? We divide it up evenly among every American, then how much is kind of your share, right? How much are you kind of responsible for using, even if you're not using it directly? So that's the way we're thinking about it. So if we look, some of these big numbers, some of these big volumes of uses, these are all different geologic commodities that you can find and that are being mined here in Ohio that you use in your everyday life. And so you can see there's lots of these that we use a lot of in our lifetime, and Ohio ranks really highly nationally in the production of all of these different commodities. So I don't know about you, but I really still struggle to kind of get my head around 1.4 million pounds of stone, sand, and gravel, right? Or what does 300,000 pounds of coal look like? If you told me I have 4 wheelbarrows of stone, sand, and gravel in my driveway, I can imagine what that kind of looks like, right? But when you say over the course of your lifetime, you're going to be responsible for 1.4 million pounds of stone, sand, and gravel, I just really struggle to get my head around that. So I thought we could do a little exercise to help kind of figure out what that kind of looks like in your day-to-day life. So 1.4 million pounds of stone, sand, and gravel. That might be things that you contribute to using by the sidewalks near where you live, the roads that you drive on, the foundations of the buildings that you live and work in. So if we take that amount and we divide it out over an 80-year lifetime, over about 365 days a year, that works out to be about 50 pounds of stone, sand, and gravel per day. That's kind of your contribution as an average American. And so you might say to me, JD, I haven't left my house for an entire week. There's no way I could have used that. But remember, that's just kind of your share based on how much we consume in the United States. And so even 50 pounds might be hard to visualize. So I think the best way that I like to visualize this is I like to say, if you're going up and down the grocery aisle, and you remember if you go down the pet aisle, you sometimes see those giant bags of dog food on the bottom level of the pet aisle. Some of those can be 50-pound bags of dog food. So you can just imagine that is approximately the amount that you'll use on a day-to-day basis. So there's a lot of other commodities just besides stone, sand, and gravel, and they have lots of other really interesting uses besides just some of the construction uses that I've been talking about. So what I'd like to do now is I'd like to throw this over to Chris Wright, who's our industrial minerals and coal geologist. And what he's going to do is he's going to go through and talk about a bunch of different commodities in Ohio, where you can find them, how they formed, and what are some of the uses that you might expect for those, and what are some of the uses that you might not expect for some of those different geologic commodities. So Chris, I'm going to let you take it from here. Just as a reminder, if you have questions, feel free to submit them in the chat. I see we've had a couple.
All right. Well, hi, everybody. So first, we're going to talk about a little bit about, I'll give you a little synopsis of bedrock geology of Ohio, because to talk about the mining in Ohio, we need to tell you a little bit more about what the geology of Ohio looks like. So here's a geologic map of Ohio. And you can see there's lots of different colors, and each of those colors represents a different time period for Ohio's history. So we've got the oldest rocks in Ohio are Ordovician age, all the way up through the brown rocks, which are the Permian age. And those rocks are all part of what's called the Paleozoic time period. Now, the important thing to know here for our purposes is that the older rocks are the pink rocks down there in the Ordovician, and then the youngest rocks in Ohio are the brown rocks of the Permian, early Permian age. So if you start down by Cincinnati down there in the southwest, you've got the oldest rocks, and as you move kind of clockwise across the state toward the Ohio River by Marietta and things like that, you get progressively younger in time. And that's important to know about because the geology of Ohio changed over time with the rocks that were being deposited in Ohio throughout these different time periods. And that is really helpful for trying to define what products were mined in Ohio, because certain types of rocks were formed during certain time periods. So we've got different mining that happens in different parts of the state based on that geology. So this next slide here, I've still got the geologic map up, but now there's a lot of different things on it. This image is kind of busy, but it's just showing you all the different mining operations that happened in Ohio during 2019, which is the most recent year we have data for. Now, you might notice there's some different trends on here. So some of the different commodities that we're going to talk about today are things like clay and shale, which are the little purple diamonds. Coal is the little plus symbols, they're orange or red. Limestone and dolomite are the green squares. Multiple commodities where you can sometimes mine different multiple things are the little blue stars. Then you've got salt with the little pink pentagons, and the sand and gravel are the little blue triangles, and the sandstone and conglomerate are the various little brown hexagons. And you might notice by looking at this map, although like I said, it is very busy, I don't want you to study it too hard, but you might notice there are some different trends in some of those commodities and where they're located. Like for instance, the green, limestone and dolomite operations are primarily in the western part of the state, although there are a few in the eastern part of the state. Whereas like the blue triangles for sand and gravel are pretty much all over the state. But now we'll start talking a little bit more in detail about those individual commodities. So the first commodity that we're going to talk about is limestone and dolomite. So limestone forms from dead sea creatures, basically. It formed in very nice, warm, tropical environments, kind of like the Bahamas are today. Think nice and tropical, warm waters that used to cover Ohio when Ohio was an ocean at one time, a shallow sea. So we had little things like sea creatures with shells that are microscopic, and sometimes bigger things like with shells like brachiopods, clams, trilobites, things like that, and corals, of course. those all lived in the ocean, and then eventually they died, and their bodies, their little shells and things settled to the bottom of the ocean and formed, eventually built up over millions and millions of years and turned into limestone. Now, dolomite, how that forms is it's basically the same thing. It's just limestone that's been altered because after it's started to turn into rock, be buried deep underground, there's different water chemistries that occur to the rock and forms adds a little bit of magnesium content to the rock, and that's what forms dolomite. Unfortunately, this process of dolomitization unfortunately destroys some of the fossils. So dolomites don't have as many fossils generally as limestone. But you can see on the picture on the left a nice picture of an outcrop in a mine of some limestone, and the picture on the far right is a picture of showing downtown Columbus within sight of a mine. So these mines are all over, even if you don't really think about it. And the middle picture is just a close-up of some limestone showing some brachiopod fossil shells.
Hey, Chris, I've got a question for you.
Yeah.
When we're talking about limestone, I know a lot of times we find caves in limestone.
Mm-hmm.
What kind of minerals might you find in a cave? And sometimes can you find a lot of different minerals like in caves?
Yeah, usually you find calcium carbonate, which is also limestone that's dissolved, and then it starts to form stalactites and stalagmites in caves in the form of calcite, which is a little purer form of limestone. You can also get things like rust and manganese dioxide forms in caves as well, form some little iron formations, as well as some kind of bluish stains on the wall, which is the manganese. You can get those a lot of times in caves like at Ohio Caverns, where I used to work as a tour guide back during my college years. So you can see all sorts of things like that in caves as well.
Thanks, Chris.
Mm-hmm. Now on this slide here, we've got our friendly geologic map. It's not as busy now because I've only showing you now the limestone and dolomite operations in the state. So now you can see a little bit more clearly what I was talking about, where I said that the limestone primarily is mined in the western part of the state, although there is a smattering of limestone operations in the eastern part of the state. And that's based on the geology, because the big limestone forming time periods in Ohio's history were during the Ordovician, Silurian, and Devonian time periods. And that's where, coincidentally enough, we have most of our limestone operations, although there was some limestone that formed later, but it wasn't as extensive and as thick. Another interesting thing is I've got this little graph on the left side of the screen here showing limestone and dolomite sales since 1960. So you can just kind of see how many tons were sold over time. Don't want you to get a lot from this graph, just you can kind of see when it went down is kind of interesting because those are times when things like construction were down because of recessions back during the early 1980s and back during like 2009, 2010, things like that. So that's kind of interesting that you can see some of these trends in these kind of graphs sometimes. Now we'll talk a little bit about some of the limestone and dolomite uses. So the main uses are things like construction, so building stones, like our state capitol up here in the picture here. You can see it's built out of Columbus limestone. Then you can break up limestone into smaller pieces and use it for things like concrete and cement and things like that, which then go into our roads and bridges. If you have bigger chunks of limestone, you can use it for protection of shorelines and along creeks and streams and things like that, and rivers from eroding way of soil and things like that, and what's called riprap. It's also used in water filtration and purification because it's water is able to run through it and it kind of acts as a natural filter. You can also, interestingly, crush up limestone and add it to molten iron and things like that in the steel industry. It reacts with some of the various impurities in the iron, and it's able to get them to kind of come to the surface and solidify, and then they're able to kind of skim off those impurities and things like that in what's called slag. You can also crush it up and use it for putting on farm fields and things like that as a fertilizer for acidity control. It's also used in our own food supplies as a calcium supplement. So in things like enriched bread and things like that, we have very small, tiny particles of limestone that are used to increase calcium levels. Similarly, it's used in animal feeds for our livestock, like our cows and chickens, to give us more higher calcium milk contents, as well as boosting egg shell production. It's also used in things like sugar refining, where it's able to react with the sugar beets and things like that, the fluid that's before the sugar starts to crystallize, and remove some of the impurities and reduces the pH as well. Some other unconventional uses you might not think about for limestone and dolomite are for things like paper. It's used in paper formation as a filler product and a whitener. Similarly, it's used as a filler product in rubber manufacturing. It's used as a filler and whitener in paints, as well as cleansers and chalk from back in school, things like that on chalkboards. Chalk is just a form of limestone, so that's something you might not think about. It's also used as a filler product in things like plastics and cosmetics, caulking compounds, and toothpaste, something you use every day. Non-gel toothpaste anyway. It's used as very small pieces, and it's used as a filler, and also it's a slight abrasive that won't really hurt your teeth, but it helps to clean them. So it's used for that. It's also used in antacids. If you have stomach acid issues or something like that, you chew on some of those and it helps neutralize some of those stomach acids. And it's also used as a whitener and filler product in things like porcelain. The next commodity we're going to talk about is clay and shale. So on the left, you've got a shale outcrop, and on the right, you've got a clay outcrop underneath some coal. And what clay and shale are made out of are clay-sized particles. So very small, fine-grained particle sizes that are usually brought into Ohio, in this case, from rivers and streams that flowed from the forming Appalachian Mountains to the east, from rivers that were eroding those mountains, and they would come out into Ohio when it was a shallow sea and start to build up over time. It can also form in lakes and streams and flooding rivers and things like that on floodplains. So that's how shale and clay is formed generally. Now, there are clay and shale mines in Ohio, and you'll notice again on here some trends. There are a few clay and shale operations that are in Western Ohio, but for the majority, most part, the majority of them are out in the eastern part of the state. And that's because they are deposited in those rocks from the time periods when the Appalachian Mountains were beginning to form and starting to erode. And that was during the Devonian, Mississippian, Pennsylvanian, and Permian time periods. So that's where we would expect to find some of those mines, are in those rocks of that age. And you can kind of see on the graph here just an overall trend that clay and shale usage the sales have been going down over time, generally. Some of the various products that are used to make using clay and shale are things like bricks. So if you have a house made out of bricks, or your school is made out of bricks, or even where you work is made out of bricks, that's all just clay and shale that's been baked and cooked. Things like pottery and ceramics. So we've got various pots and different dinnerware, as well as bathroom fixtures and things like that, like toilets, sewer pipes, big clay pipes and things like that, used for drainage and things like that, are also made out of clay and shale, as well as things you might not think about, like pond liners and landfills. So how that works is you dig your hole to make your pond, and then if you just fill it up with water, there's a chance it'll start to drain away into the soil, depending on what your soil type is. So you can use clay to line the bottom of the pond, and that'll help to keep the water in there, just because water and clay usually like to not let clay tends to not let water go through it. And similarly with landfills, you use it at the bottom as before starting to put in the waste in the landfill, but you can also use it on the top as a capper, and it just kind of helps seal in the various waste in landfills and things like that, to keep any of those waters or fluids or anything like that from draining out into groundwater and contaminating things. Other weird clay and shale uses you might not think about are, again, things like paper manufacturing, who knew? Things like rubber. It's even used in things like pencils. So here we've got a picture of a guy holding a lot of pencil leads. So the graphite pencil leads that are used, that we use, you think they're just graphite, but they're not. They're actually a mixture of graphite and clay, and then it's kind of baked and compressed together to make a stronger graphite so that it doesn't break apart and things like that as easily. So that's kind of interesting. Then we've got, it's also used as a filler product in things like cosmetics, again, plastics, antacids. It's also used as in antiperspirant deodorants sometimes because it helps just wick away moisture and things like that. It's also used in things like some shampoos because it helps to absorb some of the various toxins that might be in your hair or chemicals or oils and things like that. And if you've ever had a cat, an indoor cat at least, you probably are very familiar with cat litter. So it's used in cat litters as well because of its absorbing abilities. The next commodity we're going to talk about is sandstone and conglomerate. So as you might guess, sandstone is made up of sand-sized particles, and conglomerate is sand-sized particles as well as pebbles that are all mixed up together and turned into rock. So these formed from those rivers, again, flowing down from the early Appalachian Mountains. So as you might guess, we only find them again, like the clay for the most part, in eastern Ohio. You don't really have them in western Ohio. So because when the Appalachian Mountains were forming was during those Devonian, Mississippian, Pennsylvania, and Permian time periods. So we've got lots of sandstone mines in eastern Ohio. Some of the various uses for sandstone and conglomerate is, again, like limestone, it's used for dimension stone for buildings and things like that. So you can build walls, you can build statues, like the bridge there in Cleveland is made out of with those nice statues. It's also used for things like riprap along the rivers and streams and ponds and lakes and things like that. Another use is that you can crush up the sandstone into sand-sized particles and then mix a few other components into there, heat it up really hot, and then you can make glass. So that's how they make glass windows and bottles and things like that. You can also use it for things like outdoor recreation, for things like sand traps at golf courses or baseball diamonds, sandboxes when you were a kid or something like that that you played with, as well as for water filtration because water is able to filter through and it can remove some of those contaminants and larger particles and things like that. So it's used for that purpose as well. Some other uses that are a little less conventional that you might not think about are things like lab countertops or even countertops in your home if you've got quartz countertops. Sometimes it's used for pool table tops, although the majority of that's used for is used in slate, is used for that purpose, but it is sometimes used for that. It's used in ceramic glazes. It's used as a filler product for paints and plastics. Again, for toothpaste, similar to how limestone was, except this time it's used in gel toothpaste for that purpose. And it's also used in things like grindstones here in the middle. Used to be used in the 1800s and still used today for sharpening things like knives and tools and things like that. It was very popular a long time ago. And lots of grindstones were made here in Ohio and Berea. That's what made Berea famous, were the grindstones that were made from the fine-grained sandstone located there, the Berea sandstone. The next commodity that we'll talk about is salt. Now, you might not think about salt being in Ohio, but it is. It's just that it's not found at the surface in Ohio. We do have two large salt mines, underground salt mines in Ohio. And they're located up along Lake Erie, actually under Lake Erie for the most part. And here you can see in this image of this showing this mine map outline under Lake Erie, right at downtown Cleveland is where this mine is located. You can see down here in the picture, there's a big salt pile right here, and then the skyscrapers of downtown Cleveland. On the right side of the image, you can see some of those layers of salt, as well as some of the various impurity layers that are mixed in with things like gypsum and limestone and things like that, because salt forms from seawater. So when Ohio was an ocean, that just evaporated away over time. At one point, the ocean that was over Ohio became restricted, and all the water evaporated away, leaving behind vast salt deposits that are about 1,800 feet underground, at least in the Cleveland area. Now here's our geologic map again, showing the salt mine locations and salt operations. Now again, they should be, you would think, in the green areas, which is Silurian for when the salt was deposited. But again, it's 1,800 to 2,000 plus feet underground is where the salt deposits are in Ohio. So that's where they show up on the maps. Now these other ones you might see on the map here, like I said, these two up here are mines, but these ones down here in the middle of Ohio aren't mines at all. Those are actually salt wells. So how those work is they drill a well down to the salt deposits, and then they inject water down into the salt, which dissolves away the salt over time, and then they can pump it back up to the surface and evaporate out the salt from the water. So that's how we get lots of our salt as well in Ohio. And our graph here kind of shows the ups and downs of salt production and sales over time, just depending on how the winters are and things like that. And that's because salt's main use in Ohio, at least, is for things like ice control. In the wintertime, we've got our ODOT trucks and things like that. As they're clearing the snow with their plows, behind them they're dropping salt on the roadways, because salt is able to, when it mixes with the water, it's able to have a higher, it's able to go lower temperatures without freezing. So that's why it's used on the roadways. So that even in low temperatures, below 32 degrees, it's able to still be water, just a salty water at that point, hopefully, and keep from freezing. Now, it's also used largely in Ohio for water softening agents. So it's used to try to help remove impurities from your water, things like iron and calcium and things like that. It tries to make your water a little less hard, as they say. And another use that you probably use salt for is what you most think of is for things like French fries and for food, for seasoning and for baking and things like that, and cooking.
I've got a couple questions here about salt for you, Chris,
Sure.
that have come in.
Mm-hmm.
One is, in those salt mines that we have that are underneath Lake Erie, do they ever have problems with water from the lake making it down into those deep mines?
They do have a little bit of water that comes in, but it's not usually from the lake. It's just groundwater that's surrounding, because everywhere underground is once you get down past a few feet, like 10, 20 feet, it's usually all the little pore spaces between all the rock mineral grains and things like that are all filled with water. So there's a little bit of water that they have to pump out, but we don't have to worry about fractures or anything like that going all the way up to Lake Erie and draining Lake Erie or anything like that, because there's a lot of rock between Lake Erie and the salt mines, so almost 2,000 feet. So we don't usually have to worry about that, but there's a little bit of.
Thanks. And one more question about salt. Is the salt that they mine from those wells that you were talking about, is it the same salt that is mined from under the lake?
It is the same salt deposits. It's just a little further away, but it is all the Silurian age salt deposits. There's a couple different horizons and zones for the salt, so I'm not sure if it's exactly the same zone, but it's all the same basic overall deposit of salt. Yes.
Thanks.
Mm-hmm. So, like I was talking about, some of the other salt uses that are used, or where salt's used, are for things like animal feed supplements and things like salt blocks. If you've ever been around cattle or horses and things like that, they lick the little salt blocks to get a little extra nutrition. It used to be very popular as glazes for ceramics back in the 1800s. And how that worked is when they were firing the pottery in the kiln, they would pour a little bit of salt into the open fire, and it would vaporize and then get onto the pottery and make a nice little varnish and glaze on it. So that's kind of cool how it was used back in those early days. It's also used in things like meat packing and meat preservation, because salt helps keep bacteria from growing. And it's also used in things like drilling well muds to try to change the water chemistry so that it keeps the particles near the drill bit from gumming up the drill bit and going up into the fluid into the drill hole, as well as things like hide tanning to try to dry out the flesh on the underside of the fur. The next topic we're going to talk about is coal. So what coal is it's all just a lot of plant material that was deposited in swamps and things like that. So trees, leaves, ferns, things like that just built up over millions of years. And you can kind of see in this picture different little layers in the picture of coal here. And those are just different, represent different plants and trees and things like that over time. We've got large coal deposits here in Ohio that are mined. And here we can see that it's Coal is only found in the Pennsylvanian and Permian age rocks in Ohio. So it's only found in eastern Ohio. There are no coal mines anywhere else in Ohio. And we do have two different colors to look at on this map. We've got our orange plus signs, which are surface coal mines, as well as the red plus signs, which are our underground coal mines. We've got our little graph here showing coal production and sales over time. You can see there's been some ups and downs over time with increased production during things like World War I and World War II. And it's been on a fairly steady decline since the 1970s. But that decline has increased quite a bit the last few years because of competition for things like natural gas. And that's because coal's main usage is for in Ohio is for burning to create electricity to power our homes and things like that. So it's also used, though, which a lot of people don't know, it's used to make iron and steel and things like that, because you can cook the coal, burn it, and oxygen poor environment, and then it's able to create a lot more heat, which will melt the iron and steel, and other things like copper ores and things like that, and concentrate it and burn it and melt it into the ores that are made into steel and things like that. Another use for coal is for activated carbon, and that's used in water and air filtration systems, as well as it's used for making carbon fiber, which is used a lot of times because carbon fiber is very strong, but it's also very lightweight. It's used in things like supercars, like this Lamborghini, and in airplane wings, and sometimes in bikes and things like that, because it's very lightweight and very strong. So it's kind of interesting that coal is being used for lots of things like that.
I got a question about coal for you real quick, Chris.
Sure.
Sorry to interrupt you.
Uh-huh.
Why are there more coal surface mines than underground mines in Ohio?
Yeah, sure. So there are, go back a couple slides here. You'll notice there are definitely a lot more surface mines than underground mines. And the surface mines are generally a lot smaller than the underground mines. The underground mines usually have a much larger footprint, and usually you're able to mine a lot more coal than the surface mines because there's a lot of different regulations that go into coal mining at the surface with regard to being near waterways or people's houses and things like that, and roads and things like that. So there's a lot more of the surface coal mines in Ohio than there are underground mines, but the production, the vast majority of it comes from the underground mines. But the surface mines are still very important. And sometimes with these surface coal mines, they aren't just mining coal, they're doing multiple mining because we have coal, shale, clay, and sandstone, and sometimes even limestones that are all deposited very close together, so you can mine some of these multiple commodities together at the same time. So that kind of is interesting with coal.
Great, thanks, Chris.
Mm-hmm. But some other uses for coal that you might not think about or know about is that, well, when they burn coal, they're able to get lots of different chemicals out of the coal because it's a very complex rock. So they can get some things, and they can synthesize different things like fuel. It's used to make creosote oil, which is what's used to preserve wood for things like railroad ties. And it's used for some of those chemicals can be used for things like insecticides, various medicines, dandruff shampoos, perfumes, dyes, paints, lacquers, varnishes, explosives, insulation, and even things like the tar that's used on shingles to help hold the little sand particles together. So it's used in a lot of different things, not just burning for electricity. Now, this next topic is a little different than the other topics we were talking about before, because all those other topics, commodities, were all rocks. Now we're going to talk about sand and gravel, which is just sand and gravel. It's not solidified into rock. And that's because it's not old enough yet. It hasn't been buried and pressurized and turned into rock yet. And that's because it came down with the glaciers a few thousand years ago when the glaciers were covering parts of Ohio coming down from Canada. The glaciers were very heavy, sometimes almost a mile thick. And as they would come along, the weight of those glaciers and the pressure and rocks that were incorporated into the ice would break up the rocks at the surface of Ohio and make smaller and smaller particles, which eventually became sand and pebble-sized, gravel-sized pieces of rock. And they eventually started to, as the glacier started to melt out, they would deposit some of those sand and gravels at the end of the glaciers and where rivers would form and things like that. And that's why on the right we have our usual geologic map, but there's a lot of smatterings of red all over it. And that's just to show you some of the various sand and gravel deposits in Ohio and show you that where the glaciers were for a while, where they were slowly depositing some of those sand and gravel deposits over time. And you can see the little blue triangles are all over Ohio for the most part, wherever there were rivers coming from the glaciers to deposit those sediments. Now, sand and gravel uses are similar to things like limestone. It's used in construction for things like concretes, asphalts, dirt roads, driveways, roadways, bridges, things like that. But it's also used for things like castings, which are up here. So you might not know about how some of these things are made. How this casting process works is they have like a wax mold of an object that they want to cast, like an engine block or maybe a valve for plumbing or something like that. And they bury it in these sand boxes. These boxes fill it with sand, compact all the sand around the wax thing that they want to create. And then they cover it up with sand and make little holes down to the wax object. And then they pour in the molten metal. And then the molten metal instantly melts the wax, and then the metal starts to form into the spaces left by the wax mold. So they're able to get different things and cast them. So get things like valves or for plumbing, or even things as complicated as engines for our cars. That's how the blocks of our car engines were made, is from these sand castings. And other uses for sand are things like I talked about with roofing shingles. So we've got the sticky tar, and then when it's sticky, they put on the little sand particles, and that adds different colors and also protection to help make the shingles last longer. In some areas of the country, though, they don't use salt on the roadways in the wintertime. The salt won't really help very much because it's so cold. So they put down things like sand on the roadways to add extra traction and grit to the roadways. Another use for sand is in things like sandblasting down here in the bottom corner. So how that works is they have high pressure air being thrown with sand particles at things like metal that have either rust or paint on them that they're trying to remove, and it slowly eats away at the paint and rust, but doesn't hurt the metal. So they're able to do things like repaint it or something like that. So it's used a lot of times for that. Some other commodities, though, that we have that are technically mined, even though we don't really think about them as being mined, are things like oil and gas and groundwater. We usually think of those as being pumped, not really mined, but they are in a sense being mined. And similarly, we have things like soil that are mined in areas and brought into areas that need more higher quality soils or nutrients and things like that. Those are some commodities that you don't really think of as being mined in Ohio, but they actually are.
I got a question for you, Chris, and about groundwater. Mm-hmm. Earlier, we learned that rocks and minerals are both solid, but I mean, could you say why do rocks and minerals have to be solid?
Why do rocks and minerals have to be solid?
Yeah, does it have to do potentially with their crystal structure? I mean, this is a question we just got here, and I think it's a good one. Why do rocks and minerals need to be solid, or is groundwater considered a mineral?
Well, water is considered a mineral in some senses, like ice, because it turns into solidified water, and it's got a chemical structure and things like that. Groundwater is just kind of in that transitional state before turning into a rock, and things like that. Rocks usually we think of them as having a defined crystalline structure and things like that. So groundwater, while water eventually can be turned into ice and have a crystal structure, we usually don't think of things like oil and gas and groundwater as being rocks.
Great, thanks.
Mm-hmm. Now, we do have a couple other commodities to talk about that are things that were formerly mined in Ohio that aren't really mined nowadays in Ohio. So we have first, we'll talk about gypsum. Gypsum is an evaporite deposit like salt. Sometimes it's found with salt deposits, and it's used for the manufacture of plaster and making things like wallboard for like your drywall of your homes. It's also used as an additive for baked goods as a dough conditioner, which reduces stickiness in the dough. And nowadays we get a lot of gypsum from coal mining, actually, or not the coal mining process, but the coal burning process, because in a way to try to reduce the amount of chemicals and bad things that come out of those power plant smokestacks, we throw in little bits of limestone into there, and then it chemically reacts with the limestone, the gases and things like that from the exhaust from the burning coal, and then gypsum is actually able to be precipitated and formed. So a lot of our uses for gypsum nowadays come from as a byproduct from coal burning. But we used to mine it a lot before we had those kind of ways to try to help keep pollution down. Another commodity that used to be mined in Ohio was iron ore, something we don't really think about often, but it used to be mined in Ohio. It's usually associated with coal seams, so it's found in eastern Ohio for the most part. And it used to be used back in the early to mid 1800s for the manufacture of iron and steel. And that's actually where, during the mid 1800s, that a lot of the metal that was used for making cannons and things like that during the Civil War were made from Ohio iron and steel. Some other commodities that were formerly mined in Ohio are things like flint. Flint is a microcrystalline quartz, so it's like sand and things like that, but it's a very, very fine-grained material. And because it's so very fine-grained, it was used by the Native Americans to make arrowheads and spearheads, because as you chip away at it, it makes a really nice little sharp edge and keeps a sharp edge. Because it's able to be very strong and very fine-grained, it used to be also used for millstones and grindstones back during the 1800s to make things like flour and crush up their grains and things like that to make flour and breads and things. So that's kind of interesting as well. Nowadays, primarily the use for flint is used for things like jewelry because it can be very pretty and shaped into different jewelry. And lastly, our last topic is peat. And what peat is just a plant material that's been buried and is partly decomposed. Peat is actually the first part of the process to turn plant material into coal. If we were able to bury the peat for thousands and millions of years deep down underground, it would eventually maybe turn into coal. But we don't really mine much peat anymore in Ohio. The most useful thing it's used for in Ohio has been as a soil additive for fertilizer because it has a high organic content. But in some countries where they don't have access to coal and things like that, but they have lots of peat deposits, they're actually able to dig up the peat and burn it to make electricity and heat for things like that. So that's all I have to talk about. Now we'll take some questions and I'll pass it back to JD.
Hey, thanks a lot, Chris. That was great. I appreciate you going through and kind of breaking down a bunch of those other different uses that I didn't necessarily realize myself. I've got a question here for you. Someone asks, can you melt rocks and minerals? I think you touched on that a little bit, but could you talk a little bit about what are some of the rocks and minerals we melt and how do we do it?
Sure. So like I talked about, we can melt sand, which is silicon dioxide, SiO2. You eventually heat it up to very high temperatures, and then it'll eventually turn into glass. You can also melt salt at very high temperatures. It'll vaporize and form the varnish or the little varnish on the ceramics, like I talked about. You can also burn limestone, and that's how you make things like the ag lime and things like that, which is used for a variety of products. And that's how cement is made, is by burning limestone. It creates lime, which is able to be combined with other materials, and when water is added, it's able to turn back into a hard rock of cement, basically, a man-made rock. But yeah,
Great.
So a few of those are able to be burned, yeah.
Thanks. We have a couple questions from Mrs. McEldowney's class. They would like to know, Chris, how do we find these different minerals in these different places, right? How do people know where to go to mine these different things?
Sure. So like JD mentioned, later next week, we're going to have a talk about geologic maps. So a lot of these commodities, we know about where they are based on our geologic maps, because since the early 1800s, there's been different geological surveys in the country, the USGS, the Ohio Geological Survey, like us, and we've had geologists going all around the country and states going around trying to find all these different rocks and figure out these geologic maps. We even have geologists that can use drilling and things like that to drill down into the earth to find out what's below our feet, thousands of feet down or hundreds of feet down, where we can't see it at the surface, so that we're able to map those kinds of things as well. It's those kind of maps that are used to help figure out and identify areas where these different deposits for things are.
Great. Another question here, this was directed at you also, is Chris, how did you learn all this different information about minerals and rocks? How did you get to be a geologist?
Sure. So I've always had an interest in rocks. Even from when I was a little kid on the playground, I would pick up rocks, around the swing sets and things like that, and bring them home, or look through rocks in the yard and things like that. So I've always had an interest in rocks and geology and fossils and things like that. And eventually I knew in high school, I was like, I like rocks. When I go to college, I'm going to try to study geology and rocks. So I went to college, went to Ohio University, studied geology. And then after that, wanted to learn more about rocks to be a little more, get a little bit more information. So I went to grad school. So had another 2 years of schooling at Bowling Green State University and got my master's degree in geology. And then after that, I got a job as a consulting geologist looking for coal and things like that down in West Virginia and the Appalachian region. So that's kind of my geologic story of how I got into geology and things like that. And now I'm here working for the state, trying to help people learn a little bit more about the different geology of Ohio and different commodities that are in Ohio and things like that.
So it sounds like you had an early interest at a young age, and you just kind of stuck with it and kept seeking out more information and more education. So if you had one recommendation for maybe some kids, elementary or middle school age kids who are out there now that are interested in rocks and minerals and fossils, what maybe is one recommendation you might give them to help them pursue their interest in the earth sciences?
Sure. Just ask lots of questions, talk to your science teachers, try to get some books on geology. That's what I did back in high school. I got a college textbook on geology and started just reading it on my own because I liked it so much and was just fascinated by all the different things that you can learn about geology. Because like JD talked about at the beginning of the presentation, there's lots of different sub-disciplines for geology. And while I like volcanoes, I don't understand everything about volcanoes because that's not my specialty. And same with earthquakes and things like that. There's lots of different interest fields in geology that lots of people can be interested in. So it's lots of different things that you can do in geology. So I would just encourage them to talk to their science teachers and things like that. Try to get some books and information, watch different webinars and things like that about geology and rocks, and just try to learn as much as you can.
Great, thanks, Chris. And I think we have time for a couple more questions. So if you have a last-minute burning question, feel free to submit it now. Chris, one of our last questions here is somebody is asking, is there gold, silver, copper, or diamonds in Ohio?
That's a good question. We do occasionally have some gold and some diamonds that are found in Ohio, but they're not native to Ohio. They were brought down from Canada where there was some gold and some diamond deposits and things like that the glaciers brought down, like they did with the sand and gravel. So we do sometimes find people that go out and pan for gold or pan for diamonds in the various stream deposits and things like that, and sand and gravel deposits. You can find very small amounts of gold and diamonds, but I wouldn't quit my day job and go look for that because it's very small amounts. Because it had to travel such long distances and it's been spread out across the entire state. It's not like the California gold rush where they would look in streams and things like that very close to the gold deposits so that you'd be able to find lots of gold or diamonds and things like that. But there are diamonds and gold and things like that that can be found in Ohio.
Okay. And I've got a question here about coal.
Mm-hmm.
You talked about interesting minerals and chemicals that we can get from coal and what they can be used for.
Yeah.
Is there a way to get those without having to burn the coal?
You can add some different chemicals and things like that to them to try to help leach out some of the various chemicals and things like that. You can get some things like rare earth elements or sometimes entrained in coal as well. So we do have different things like acids and things like that that we can put in the coal and things like that to help get them so that you're not burning them. But those chemicals also give off byproducts and things that are also harmful. So you have to make sure to contain them and things like that and remediate and all that sort of things as well. So, but yeah, there are ways to get it other than just burning it. Yep.
Great. I think this will be our last question here. This is from Blaine. Is it possible for conditions like earthquakes or other activities to create coal from peat, or is it only time that makes coal from peat?
Sure. The main thing is pressure and temperature. It's not just time. Usually those two go hand in hand because to get buried deeply and have lots of rock weight on top of it, which gives it the pressure, they usually go hand in hand. That it takes a long time for that to happen, for the rocks to build up slowly over time and get buried. But you could have peat that happens to be forming near a fault or something like that, and then you could somehow have like a plate tectonics kind of collision, and a continent starts to move and thrusting over on top of these peat deposits, and that would help add the pressure and heat to the peat deposit, and it would be able to turn into coal more quickly. So that's one way of being able to do that. But the sheer fact that it would take lots of rock to be able to move very quickly and heavily over on top of it would take quite a long time to probably move as well. So it wouldn't be instantaneous or incredibly quick. But yeah, so.
Great. Hey, thanks a lot, Chris. And I just wanted to thank everyone for joining us today for our kickoff event here for Earth Science Week. Don't forget, you can follow us on our Facebook page, Ohio Geological Survey, or by going to our website, geology.ohiodnr.gov, and searching Earth Science Week to check out all the upcoming content and webinars that we have for the next week to celebrate Earth Science Week 2020. I'd like to thank Chuck Salmons, our producer today, as well as I'd like to thank Chris for going through and giving us that excellent rundown of all the different geologic commodities that we have in Ohio in our everyday lives. Thank you all very much for joining us, and hopefully we'll see you next week.
Bye.